Now we're moving into Sig Figs, something that's very, very critical as we move forward with chemistry. It will be with us throughout the rest of the year, so it's something you really, really want to make sure you understand and to put into memory now, and it will save you a lot of heartache as we go forward. So we practiced a little bit with Sig Figs, and in this situation, I have this structure here that give you the width is 6.87 centimeters, the height is 0.05 centimeters, and the length is 17.9 centimeters. I first asked you to calculate the area. We know this equation. I'd provide it for you on the test if I asked you to do this. So area is length times width. So I'm just going to multiply my length, 17.9, times my width, 6.87. And when you leave it in the calculator, you get this. Your calculator may even carry it out even further than this, but to determine sig figs, we must, in doing the situation multiplication, I'll talk about this more in a second, or specifically to the rule in a second, but I have to look at my measurements. I'm looking for the least significant measurement. Or the measurement with least number of sig figs. And so both of them, 6.87 has 3 and 17.9 also has 3. And we're going to learn the rules of how to figure that out here in a second. So my answer can't be 122.973. I can only have 3 sig figs. So I realize I have to round my 122 has to round up to 123. So I look at the next digit over to the right, which is 9. The rule is going to be 5 or above we round up, 4 or below we keep it the same. So it's above 5, so I bump my 122, rounds up to 123. Now the other critical thing here about science, and this is where people also lose points, especially in chemistry, because we're so used to the math aspect of it. Now in chemistry we have units. It's actually applied math, so every number better have a unit. There are a couple of numbers we go through that do not require units. However, about 99% of the time when you work with chemistry, you better have units with a number, or that number means nothing to me. I could be looking at 123 miles. I could be looking at 123 seconds. I could be looking at 123 yards, 123 feet, 123 inches, 123 meters. What is it? So it's very, very important that not only do we show the number with the correct number of sig figs, but we also must show the units. When centimeters are multiplied by each other, then we get squared. The next one, we're looking at volume. Volume of this rectangle is length times width times height. So now all three numbers are multiplied. And I get this answer in my calculator. In that situation, I know this can't be correct, but I have to look at sig figs. Now in this situation, looking at sig figs, the number that has the lowest number of sig figs is actually my height. Its zeros out in front are just basically placeholders. They're telling me that my 5 is at the 100 spot. So I really only have one sig fig. So my answer can only be 6. So I look at 6, look one digit over to the right, which is 1. 1 is less than 5, so I just keep the number the same. We were 4 below, we keep it the same. But it must have units. Now centimeter times centimeter times centimeter is now centimeters cubed. Next situation, we're going to calculate the sum. Now we're going to add these up, and it's length plus width plus height, and now we have the same numbers, but we have to follow a different rule for sig figs. And when we got this, we realized, well, now we're addition subtraction. Now we're looking at the least number of digits to the right of the decimal. And there's situations where you can worry about if the zero is significant or not, and there's more specific rule, least number of sig figs to the right of a decimal. I'm just going to keep it simple. About 99.9% of the time it works, is least number of digits, so least number of numbers to the right of a decimal. As I look back at my measurements, the number that has least number is actually 1. So my answer can only have 1, so I'm going to keep the 0.8. I'll look to the right, 2 is 4 below, so I keep my 8 the same, and the 2 just vanishes. Now in the centimeters, because we're adding here, the unit remains the same, just place centimeters. But another thing that's now important is actually making the measurement with the correct number of sig figs. And this is valuable because not only, sometimes I will give you the number, and you'll be following the sig fig rules. Other times you'll be making the measurements, then you'll be using your measurements in the calculation. So you have to make sure your measurements have the correct number of sig figs. And this rule of thumb here, as we practice this, we state what we know plus 1. So in the first situation, I know 10. In this situation, I know 10.0 for sure. But I'm going to make a guess. I'm going to say, well, 10.07. For B, I know 10.2. Now let me stop here for a second. Between 10 and 11, there are actually 10 lines. And so we have these spaces, so each of those is a 0.1. So 10.1, 10.2, 10.3, 10.4, 10.5, or 10 and a half, in other words. But I know 10.2 for sure. So I know that I guess beyond that, making just an educated guess, I state what I know, 10.2, and at the end, it's not quite 10.3, it's 10.23. So next one. Next one I believe is right on 10 and a half. So it's 10.5 plus 0.0. Always add one. Always make a guess, basically. And another one is 11.0, and I believe it's right on 11.0, so let's say 11.00. And we'll get practice with this. So again, just remember making measurements or doing calculations, you should not keep more digits in a number than are actually justified. So that's basically stating what you know plus 1. And Sig Figs in a measurement, all values or digits known precisely plus 1. That's why I state what you know plus 1. Let's keep it simple. And we practice again. We have between 9 and 10 centimeters here. So A is 9.2. I know for sure. I make a guess. I believe it's just past the halfway point between 10.2 and 10.3. So I say 10.26. Next one, B, is 10.8, almost 10.9, but it's 10.88. Next one, 9.0. Now, what's unique here in this middle one here is we don't have the dashes for the 10 spot. All we know are the 1 spot. The only thing we know is 1s. So you know the 9, the 0.0 is a guess. For letter D, you know the 9. It's not quite up to 10. It looks like it's a 0.8. So the 0.8 is your guess. You're stating what you know plus 1. And the last one, again, we have 10th spot, so that means we'll always go out to the 100. So a rule of thumb here is this: you look at your piece of equipment that you're working with, and it will have a scale that you're working with. That scale, the rule of thumb is take what that scale gives you and add 1 digit to it. So you'll have some, like graduated cylinders, that give you to the 1 spot. So your measurements better be out to the 10th. You have some graduated cylinders that will give you to the 10th, so your measurement needs to be out to the hundredths, and so forth. So that's kind of how we're working with this situation. Now, how do you determine sig figs in the measurement that it's already been recorded? So these are your sig fig rules. And it's very, very important. This next part is critical. This is something that has to be put in the memory, because now we're looking at just individual numbers, and based upon individual number, what digits or numbers within that overall number are actually significant. How many of them are significant? So the first rule is this: every non-zero digit in a measurement is actually significant. So every non-zero. So I give you a number. Now you're not making a measurement. I give you a number. Like it's 47,357. None of them are zero, so I can safely assume that all 5 of those numbers are significant. If I gave you 25, you have 2 digits, and the other one's 0, so you can actually make the assumption that you have 2 sig figs. The next step now is going to focus on the zeros. Really, the zeros become the major character here as we're going through this. So the first one is sandwich rule. So my zeros get sandwiched between 2 non-zero digits. Now 1 up until 9, they get sandwiched there. So I see 1007, my zeros are sandwiched. That makes them significant. 305, my 10 is sandwiched. That means I have 3 sig figs. Now here's the key aspect here, and really the only point where we're going to really deal with numbers or zeros not being significant, and that's when they're out in front of a number. And when they're out in front of a number, they're actually just classified as placeholders. They have no significance. So in this situation, you see the 0.00283. Well, the zeros are just placeholders. The 283 is my sig figs. My 0.98 is actually significant, but 0.00006, my zeros are just placeholders, tell me where my 6 is beginning, but I only have 1 sig fig in that actual measurement. Now at the very end, this is numbers at the end to the right of a decimal are significant. Now I'm going to have mercy on this, because the numbers at the end of the zeros at the end of a number, are really ambiguous unless you have a decimal. A decimal gives everything significance. When you have if someone has a measurement, a number, then a decimal at the end of it, that means they used the proper equipment. They actually gave them that precision. For example, the 2.060, those zeros are at the one zero is sandwiched, but the other zero is at the end of the number. But again, it's following the decimal point in a whole number. So there has been a whole number in front of it. It makes it all significant. So I have 4 sig figs, and the last one I have 4 sig figs. Now zeros at the end of a measurement where there's no decimal point are actually ambiguous. And yeah, this word's going to be kind of so-so. We're going to play with this one. I'm going to kind of work with you on this one. That last zero, if there's no decimal at the end, we really don't know if it's significant or not. And so in this situation, we're going to say zeros at the end of a number are not significant. Now 120, I could say there are 2, possibly 3 sig figs. I know the 1 and 2 for sure. The 0 could be significant, but I don't know. But we're not going to worry about that ambiguity. We're just going to just say straight up 2 sig figs. 3,000, I have 1 sig fig, and 1 million, I have 1 sig fig. Now if I put a decimal at the end of that number, which isn't necessarily the correct format, it would automatically make the zeros at the end would automatically become significant. It'd almost be like the sandwich rule. But since there's no decimal at the end of a number, they're just ambiguous. Once again, acting as placeholders. So we went through the practice here. We had 54,320. The zero at the end is significant because there is a decimal. And so both those zeros at the end, so we have a total of 6 sig figs. My next one is 0.00. Those zeros are just placeholders, so the 4550, I have 4 sig figs. Next one, 151,309. The zero is sandwich. It is sig figs. It's 6. 10.54 has 4. Now scientific notation, very, very beneficial. If a number is put in scientific notation, you don't have to worry about the rules. That's beautiful. You don't have to worry about the rules. You just count the number given to you. So I have the 5, I have the 2, and a 0. All 3 of them are significant. And the 15,000, that's where we ran into ambiguity. So we just say 2 sig figs. Now when completing calculations, it's often necessary to round a number. And so the rule of thumb when we round a number is we're going to look at that number, next digit to the right, and we're going to ask this question. 5 or above, we round up. 4 or below, we keep it the same. Or we just drop it off, depending on where it's located, to the right of the decimal or to the left of the decimal. If it's to the right of a decimal, you just drop it because it's no longer significant. For example, 0.753, right now it's 3 sig figs, but I want my rule of thumb is I want these answers only at 2 sig figs, so I look at the 3, it's 4 below, therefore I drop it. I'm not going to leave it. I have to drop it. If I left it, it would still remain as 3 sig figs. I literally drop it off, so it's 0.075. My 107.0. Now in this situation, I want 2 sig figs, so I have 107. What I realize here, 107 is going to round up to 110, and yes, you have 2 sig figs. So how many sig figs we practiced? We have 2. We went through this and practiced it. 4, 3, 2, and 2. Now, I left this there because I do this with my honors. Since that 0 at the end, we weren't the one that made that measurement. That 0 at the end of 560 could be significant, or it may not be. So in a situation though, for us, don't worry about it. We're just going to say that 0 is ambiguous, and we're just going to say 2 sig figs. And then we went through some practice here and this whole process. This is just practice again for rounding and stuff. Make sure you understand this. Just more practice, 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 practice. And that's the key, because remember, sig figs are going to stick with you through the rest of this whole year, and it's something that can cripple you if you don't, again, put it towards memory. But practice is going to really help you out. The last key is this. When we multiply and divide, they have the same rule, or if we add and subtract, they also have the same rule. So what are we dealing with when we multiply and divide? When we multiply and divide, reading the definition can be confusing. Just think about this. You're looking for the measurement with the least number of sig figs based upon our sig fig rules. So if I look at my example there, 4.56, that has 3 sig figs. My 1.4 has 2 sig figs. Therefore, the measurement of the least number is 2. Therefore, my answer can only have 2. My 6.38 has to round up to 6.4. So my 8 being above 5 rounds my 3 up to a 4. So I have 6.4. Now this applies whether you're doing a multiplication or it applies if you're doing actually division as well. So we practice through that. Now addition, subtraction. This one's easy because this one you don't have to worry about the sig fig rules. Remember, addition, subtraction, you don't have to worry about those 5 sig fig rules. All you're looking at is a measurement with the least number of digits to the right of a decimal. And we're going to count 0 as a digit. It's fine. Don't worry about if it's significant or not. Least number of digits to the right of a decimal. So I see I have 12.11, that has 2 digits, 8.0, that has 1 digit. 1.013 has 3 digits, therefore my answer can only have 1. So if I get my answer, 21.123, and it rounds up only 1, so I can only keep the 0.1. Look at 2, 4 below, I drop it off. So it's 21.1. So we go through this practice. Very, very important you understand these sig fig rules. Critical, critical, critical. So this is another little slide I showed you, just showing you again the rules, multiplication, division. You're looking for the measurement with each number of sig figs. That determines the sig figs in your answer. And then for multiplication and division, both have the same rule. If we're dealing with addition and subtraction, then we're looking at the least number of digits to the right of the decimal. So it's pretty easy looking at here. We see my 0.1 only has 1 digit to the right, therefore my answer can only have 1 digit to the right of a decimal. And we look at it here, doing this way, I see that my 0.70 has 2, therefore my answer can only have 2 digits to the right of a decimal. Again, the nice thing about this is you're not worried about the actual 5 sig fig rules.